I'm Mark Huckel, the Senior Advisor to the Pacific Telecommunications Council. We're pleased this morning to continue with our plenary sessions and two very interesting presentations coming up, I hope, for you. It's my pleasure, first of all, to introduce to you our next speaker, Mr. Greg Wyler. As you can see on the screen, the CEO of O3B Networks, a new satellite venture I'm sure many of you have been hearing about over the last several months. O3B is building and launching a new medium Earth orbit MEO Ka-band satellite network. It's a network designed to provide high-speed internet connectivity, specifically in the developing world. It has many features technologically to make that possible, and with the desire then to deliver near fiber-like services at affordable prices. So this is going to be a very interesting talk, I think, and Greg is here and waiting to go here in the wings, and is promising to have his network up and running in 2010, right, Greg? Please join me in welcoming Greg Wyler.
Thank you for inviting me here. Thanks to Pacific Telecom Council and also the PETA group is in the Pacific Pacific Islands Telecommunications Association. Has been very helpful, and appreciate all the interest because I think our interests are aligned. I think we have a mission at O3B, which is to provide connectivity to the unconnected and to do it in a way that's affordable and allows everybody to get access. And that mission is echoed by our shareholders. We're funded by Google, who everybody knows, and Liberty Global, which is a very large cable and television operator worldwide, and HSBC Bank. And that mission pervades all of us, and it's really the reason why we exist. Just a little history of how we got to where we are, how the other 3 billion are unconnected at the moment. In the 1990s, we built out a very big fiber network and spent a lot of money on that network, but it mostly connected the metropolitan areas, the New York and the London and the very wealthy sections of the world. And a lot of those carriers, they ended up going bankrupt and had to change their pricing regimes. It turned out that long-haul fiber for very small amounts of bandwidth was not economically feasible. So subsequently, after going bankrupt and reselling that fiber at very low prices, the carriers, the telecom carriers, could provide the 20 megabits of access that you get today at your home for $20 a month in the developed world. From there grew companies like Google and Yahoo and Web 2.0 applications and a whole economic growth in industries that blossomed from really what was a slight misjudgment on the part of the bondholders at one time in the 1990s. There wasn't prescient decision to do this. And the problem really is that these people down here, us in the unconnected world, the other 3 billion, we don't have that big network. We don't have the $70 billion donation coming to us. And in fact, what you'll see is that the unconnected, the geographic size of the unconnected world is actually much larger than the size of the connected world. And it's from that O3B came about, which was to try to help bring that fiber quality connectivity, the low latency connectivity, to everybody so we can all participate economically. And it's something which we're trying to do in an inclusive nature or method. We're getting everybody's advice and ideas on pricing and on how we should approach the sales process. And we look forward to all of your comments on it. So where does O3B fit in the picture? It's effectively fiber over satellite. It's 122 milliseconds round-trip delay. It is, if you look at a geo satellite, they're typically very low bandwidth and very high price and very high availability. You can't beat a satellite for the availability aspect. It has the ability to reach deep into the farthest corners of a country and connect the unconnected. It's wonderful for that. The problem is historically it's meant very high latency, which translates into lower quality internet services. And of course, the costs have been high. Fiber, on the other hand, is great. You can't beat it for its speed. But it lands on a beach, it lands in the capital city, and then how do you get it out to the rest of the population? I'll give you an example of the latency differences, and this is something that's important to consider when you're considering any network, is What is the latency? How many milliseconds does it take to get to your content? And as we move our content from flat file HTML of the 1990s to the Web 2.0 interactive cloud computing of today, you'll see the imperative to have low latency will continue to increase. I'll give you an example here. We've got 3 Wall Street journals. One is running at 50 millisecond latency. The other one's at 122, which is similar to what our network or any long-haul fiber would bring. And the third one is a geo satellite of 600 milliseconds. And the only difference between the 3 of these is the latency. They're all on a 10 megabit Comcast pipe. So we'll start it now, and you can watch them race against each other. And you can see down here in the lower left-hand corner, you can see the server-side calls as they go out and they try and pick up capacity, pick up the information from the server. And in 10 seconds, boom, this is what we experience in the USA. And then this is with adding 122 milliseconds of latency, it's about 15 seconds. Now, the other side of that satellite pipe is experiencing what you're seeing right now. You're noticing that the Web 2.0 applications like the stock indexes, which are server-side calls, and the advertising and this thing, they're still taking time to get from the server. And it's back and forth and back and forth. And this time lag is really the thing that we're trying to overcome. We want to bring everybody over to the left side of the screen so that they can participate and develop the same types of really cool applications that we're used to in the developed world. Just to give you a little bit about where we're located, what our satellite constellation will do, and then I'll show you a little video clip. With 4 satellites, we cover a strip along the equator, and then 5, and then 8 satellites. And we're launching 8 is the first step of the system. And you can see the amount of coverage that we have. And each of these locations, we can provide that fiber quality connectivity. I'll show you a quick video that was just recently done on CNN, which is kind of instructive about our mission and what we're trying to accomplish. You might enjoy it.
Most people in developing countries are not connected to the internet. That inspired one company and a cause, O3B.
O3B stands for the other 3 billion people who are not on the internet today.
Greg Wyler realized a disconnect while helping to build a web network in Rwanda about 4 years ago. Cable landlines and current satellite services price most people out of easy access. O3B is launching its own network of satellites in 2010 that, it says, will provide cheap internet access to people in remote areas of Africa, Asia, the Middle East, and Latin America.
There's another 3 billion people who are really off the economic grid. We want to sell to them, and we want them to be selling to us.
O3B has received millions in funding from big-name partners like Google. But it's not about aid. O3B is in business to provide an untapped market, the ability to get online.
We've recognized that the importance is to let the people on the ground build their own economies. We're trying to reduce the barriers to entry for people to start internet service providers in the local areas.
And being linked in gives the world a leg up.
Having more people on the web is good for all of us. So that overlays our mission and what we're trying to accomplish. I'll show you how the system works. You'll see it's a satellites that have